Hello, this is the question 7 of homework 9, and the question is: show that the random telegraph signal is a strict sense stationary process. So we know that the random telegraph signal is a random signal, and it turns between from -1 to 1 and randomly. So it is either 1 or -1. So what we want to show is that it is a strict sense stationary process. So when we get an random telegraph signal, and we can write it in a probabilities uh, form like this. So maybe we have y tn, it is equals to 1, and y tn minus 1, it is equals to 1, and we have y t1 equals to 1. So it can be write in the conditional probability form, which is p y t n equals 1 on the condition of t n minus 1 equals 1 and y t1 equals 1, and multiply the y n minus 1 equals 1, and also y t1 equals 1. So all of them can also write in the conditional form, which is p y tn equals 1, y tn minus 1 equals 1, and so on, and y t1 equals 1. This is y tn minus 1 equals 1 on the condition of y tn minus 2 equals 1 and y t1 equals 1, and multiply many of them, so the last one is y t1 equals 1. So because the random telegraph signal is a memoryless process, so we know that when it is a memoryless process, we can uh, ignore the this part. So the probability form we can write it is p y tn equals 1 on the condition of y tn minus 1 equals 1, and multiply the second part is yp yn minus 1 equals 1 on the condition of y uh, tn minus 2 equals 1, and so on at y t minus 2 equals 1, and so on, and the last part is p y t1 equals 1. So we can now know that this part y tn minus 1 tn equals 1 y tn minus 1 equals 1, and so on can be turned to this form, and we know that this part is, so it is equals to e minus lambda, and which is tn minus tn minus 1, and multiply the cosine h lambda tn minus lambda tn minus 1, and multiply this part is also the same form, when e minus lambda and tn minus 1 minus tn minus 2, and cosine h lambda tn minus 1 minus lambda tn minus 2, and so on. And the last part y t1 equals 1 is equals to 1 over 2. So because it can be turned in this form, and also it can be returned to this form like this, which is p y tn plus epsilon equals 1, and on the condition of y tn minus 1 plus epsilon equals 1. So this is can be transformed in this form, and this is also can be transformed in this form because uh, this part is only depend on the this part minus this part, and the Tn plus epsilon minus Tn minus 1 plus epsilon is equals to Tn minus Tn minus 1. So this can be retransformed to this form, and also we transform all of them like this, which is p y Tn minus 1 plus epsilon equals 1 on the condition of y Tn minus 2 plus epsilon equals 1, and so on. And this, which is p y t1 plus epsilon equals 1, it is also equals to 1 over 2. So this part can be transformed in this form. And because it is a memorized process, so we can add the rest part to this again, so which is we can transform to the form like this, which is y tn plus epsilon equals 1, and multiplied together it is y tn minus 1 plus epsilon equals 1, and so on. So the last one is y t1 plus epsilon equals 1, and because the probability of this is equals to the probability of the original one, which means 1 tn minus 1 t1 plus the same epsilon, it has the same probability. So it is only depends on the tn minus tn minus 1 and so on. So we know that the process is a strict science stationary process. So the proof is